This is going to be an introduction to the trigonometric functions and their graphs. But as we begin to think about those, I want you to think about an example. Could you give me an example of a behavior that repeats a particular pattern over and over and over? For example, the seasons actually rotate. We start with the vernal equinox on March 21st. Then we go to the summer solstice on June 21st. We rotate around to summer, to the autumnal equinox on September 23rd. And then we rotate to the winter solstice on December 21st. And then we start the whole cycle over again. And we go spring, summer, autumn, winter. Spring, summer, autumn, winter. So that's a pattern. Also, the high tides, low tides that we experience fall in response to the gravitational pull of the sun and the moon. So as the earth rotates around the sun and the moon every 24 hours, we rotate between low tide to high tide, low tide to high tide. Our sleep cycles follow a pattern of being in REM sleep and then different levels of sleep. So that's another pattern that you can experience. Even our heartbeats or breathing patterns, inhaling and exhaling, okay, have a rhythmic pattern to them. Even business, it seems kind of odd, but even business can have this repetitive cycle. You have kind of an expansion in a time of prosperity where you kind of reach your peak. Then there may be a slowdown or a recession, possibly even a depression where you get to a low point, and then at some point you begin to recover and then expand again and go back to prosperity and peaking, and then continues over and over again in that particular cycle. Even within music, your harmonics different have a rhythm or a pattern to them. So this idea of a pattern, when you think about it with respect to trigonometric functions and their graphs, that characteristic of following some sort of pattern is called periodic. Periodic is a behavior that repeats a pattern infinitely. We rotate from, spring, summer, autumn, winter, spring, summer, autumn, winter. And it basically takes 365 days or 12 months to go through that particular pattern. And so that is a periodic pattern. And the period, which is the time it takes to complete one full cycle for the seasons, is 365 days or 12 months. Another example would be, again, the idea of high tide and low tide. And again, they vary from low tide to high tide and back to low tide about every 12 hours. So that is a periodic behavior that has a period of 12 hours. This idea of periodic behavior can be modeled using trigonometric functions, because if you think about it, let me see if I can maybe sketch you a little picture here which may help you see this idea. If we think about the unit circle, and if we start somewhere on that unit circle at point P, let me get hooked up here. Okay, and I get to, if I'm thinking about my unit circle, or really any circle, it doesn't necessarily have to be a unit circle, and you can pick a random starting point on that circle. So if I just pick a random point and I start that cycle and I rotate a full revolution, which is 2 pi, I come back to the same point. If I do that rotation yet again, so that now I've gone 4 pi, I'm back to the same point. And I can continue in that manner. I can pick any random point, and if I go the full revolution or the full distance around the circle, that one full cycle, then I'm returning to that same point over and over again. So, in a sense, when we start thinking about graphs within the 2 dimensions of the coordinate plane, where we can actually put or graph trigonometric functions on our coordinate plane in 2 dimensions, we use the traditional symbol x. Actually, what we're doing is we're kind of unwrapping that unit circle. So I have a neat little video here that I've inserted the link that will actually show you that, okay? It'll show us that idea of unwrapping the circle. For example, here's our unit circle, and I want to look at the sine function. So if I begin at point C and I rotate all the way back around to where I started, you can see that I can get what's called the sine curve. Okay, I can rotate backwards. And again, you can watch it move. And I can rotate all the way back around. Okay. I can also see, there's the sine. I can do the same thing for cosine. Again, I pick a random starting point and I can rotate all the way around the unit circle in the positive direction, and it gives me the graph of the cosine curve. I can rotate it negatively, and again, you can see it moving and giving me different values back to where I started. Okay, so basically the idea of what we're going to be looking at is taking our unit circle and we're going to unwrap it. Okay, now let's look at tangent. Tangent's a little bit different. But again, even if I start at that starting point, any random starting point, and I rotate around the unit circle, one of the differences with tangent is you'll notice it has some breaks in it. And we'll talk more about what those breaks are a little bit later. But I can rotate all the way back around. I can rotate negatively. Okay, so the idea that we're going to get into now is we're going to begin looking at the 2-dimensional graphs of the 6 trigonometric functions that we have been discussing. And we're going to look at them in 2 dimensions and how to create that picture within our rectangular coordinate system.